As we saw in the outline of the collection framework that there are many classes in the collection framework. And at first it is a bit difficult to understand all the classes, how they relate to each other. So I have created a very basic UML diagram that shows the relationships between different collection classes. As we can see that almost all the collection classes, major collections like queue, list, set, they all extend or implement ultimately a single interface, which is collection. And it is the root interface of the collection framework. But even this interface, this extends another interface, which is iterable. So we'll start from the iterable first, and then we'll cover the collection framework starting from the collection interface. So if we go to the collection interface, which is basically the root interface of the collection framework, then we see that it extends another interface, and interfaces can extend another interfaces. So let's go to the iterable interface. It basically says, the documentation says, okay, by the way, how do we open these classes from the JDK? To do that, in Eclipse, press Ctrl Shift T, keyboard shortcut Ctrl Shift T, and type any class. So let's say collection, and we can open any class from the JDK. And to open any class from the hyperlink, simply use Control and mouse click. Okay, so here is the iterable interface, and it has one abstract method, iterator, that returns iterator. Then there are two default methods for each, which accepts a consumer, and another one is spliterator that will be used by streams. We will be focusing on iterator. So iterable interface says that whoever is implementing this interface must provide the implementation of iterator that should return an iterator, an instance of the iterator. Now iterator is another interface which says that this is a way to iterate over a collection. It means a collection would have some values. And if we want to perform a loop, if we want to access elements one by one, then we need an iterator. The implementation of an iterator will provide us the access to the collection elements one by one, so that we can do something with them. Maybe we simply want to print the elements, or we want to perform some operation on each element. To do that, we will use iterator that is provided by the JDK. But because this is an interface, so the implementation must be given by the collection. Whatever collection we are using, that collection is responsible to implement the exact implementation of iterator. All right. Now iterator has three main methods. Has next, which basically says that if we are iterating over a collection, then we need to basically apply the condition, is there a next element in the collection? So that is done by the has next method. It returns a boolean. It simply checks if there is a next element in the collection in the iterator. All right. Now, how do we access the next element in the series? We use next method. So the next method returns the next element in the iteration. So we have two methods, has next and next. Then if we want to remove an element during iteration, then we can use the remove method. As you can see, it's a default method, and by default it throws unsupported operation exception. That means it has to be implemented by the implementing class. Okay, so iterator is a way to iterate over a collection to access elements one by one. Once we call the iterator method, then we get an iterator for a collection. Okay. So if we go back to the UML diagram, we see that the collection, that is the root interface of the collection framework, it extends iterable. It means all the collection classes in the collection framework are iterable. They will have an iterator method that will return an iterator specific to that collection. If we are using a list, then list would have its own implementation of iterator, because the way we access list elements would be different from the way we would access elements from a set. So set would have its own implementation of iterator, but ultimately all the collections would have an implementation of iterator that would return an instance of iterator. Alright, it's confusing, but it is how it is. The relationship between the collection and the iterable. So collection extend iterable and iterable returns iterator. And then we loop over the collection using iterator. So let's see a quick demo of the iterable and iterator. Okay. So for example, let's say we have a list here. List L equals to new array list. So we will be using an array list. Then we added 4 elements in this list. We will cover list, set, everything in future videos. This is only to demonstrate the use of iterator. Okay. Now, how do we access these elements one by one? To do that, we know that all the collection extend. Okay, let's go back to the diagram. So because we are using array list, which is here, array list extends abstract list extend another interface or implement another interface list extends collection interface, and collection interface extends iterable interface. So we know that array list would have some method which will return an iterator. And that's how we are going to access each element one by one from the list. So if we see, then list has a method iterator here. It returns an iterator and the type would be string. Why? Because we are having a list of type string. All the elements in the list, they are string. So the iterator would have a string data type. Now, how do we access it? So we will loop over the collection, we will loop over the list via iterator, and we'll say while it, which is basically an instance of iterator dot has next. It means loop over the collection until we see the end of the line. If we have the next element in the collection in the iterator, then keep going. So while it dot has next, then we want to say that get me the next element, which is next method from the iterator, and it will return a string value because the iterator is of type string. So we say string val equals to it dot next, and maybe we can simply print it val. So we see that all the elements were accessed from the iterator from the list, and we see all those elements on the console because we are using system.out.println on that value. So that's how we use an iterator. Now, if we go back to the iterable, it says that implementing this interface allows an object to be the target of the enhanced for statement, sometimes called the for each loop statement. And since all the collection classes implement this interface indirectly, so that means all the collections can be the target of this enhanced for loop. What does this mean? It means if you see here, this is how we iterate over the list. So first we need to get the iterator, then we need to trigger the while loop with it.hasNext, then we call it.next, basically has next and next methods from the iterator. There is a better way to do the same, and which is the enhanced for loop or for each loop. What is the for each loop? It is a shorthand of the traditional for or while loop using iterator. So it says that something like this. So first thing is we want to iterate over a collection. In this case, because we have a list and that list has a reference variable name L. So we want to iterate, in this for loop, we say that we want to iterate over this list. Now, for each element in this list, I want to do something. That is why the name is for each loop. So it says for each element in this list, I want to do something. I want to get the elements from this collection. And the type of the element in this collection is string, because we are adding strings to this array list. It means for each type which is of type string, and we name it here, basically the name of the variable, we can name it anything, then a colon sign. That is the syntax of for each loop. It says that for each str, the name that is given by us, for each value in this list, I want to do something. So I want to, what I want to do is I want to print them on the console. So if we run this code now, we see the same output, but using the for each loop. And if you notice, we don't have to deal with the iterator directly. This is done by the framework, by the Java runtime under the hood. And why can we do this? Because we are using list, and all the collection classes, they implement iterable, and the documentation says that if a class is implementing this interface, then this class can be the target of enhanced for loop. So all the collection in this example, although we are using list, but the same thing can be done using set or any other collection. Okay. So there are two ways to iterate. One would be to using the iterator directly, and the another one would be using for each loop. So the syntax, just to revisit the syntax again, we use the for, then the data type of the values, in this case string, we name it anything that we want. So in this case, we name it str, which is basically a variable name, and then L, the collection that we are basically focusing on. So we want to iterate over L, and that's how we get the individual values from the collection. Okay, so I think that's pretty much it on the iterable and iterator, and we will see more examples on this when we focus on the individual collections. All right.